In this problem, we're going to be considering air pollution and how does it affect visibility in our atmosphere. Okay, they are telling us to consider the situation for NAAQS standard 24-hour limit for PM 2.5. The NAAQS is National Ambient Air Quality Standard, okay? The PM 2.5 is fine particles with a diameter of 2.5 micrometers or less. Okay. Now the limit is 35 micrograms per cubic meter. They want us to find the estimated visual range when we have this many particles in the atmosphere. So the person is looking, and in the air in front of him we have this many PM 2.5 particles mixed in. How far is he able to see? For this, we're gonna use the Koschmeider equation, and this is actually gonna help us find the visual range, but think of it that from the person, it's gonna go all the way to the estimated distance where an average person can barely tell the difference between a mountain, a skyscraper, or some object against the sky. Okay, so that's how far this formula is estimating the distance. Now LV is the visual range, equal 1200 kilometers micrograms per meter cubed divided by the particle concentration. So for this step, all we have to do is take our particle concentration, which is the national standard for PM 2.5, plug it in, 1200 divided by 35, and that's gonna give us a visual range of about 34.3 kilometers or 21.3 miles, depends what you're working with. Now for the next question, they want us to estimate what would be approximate concentration of particles in the atmosphere when, let's say, you're out in the wilderness and you can see even a mountain that's at 100-mile distance. So let's find out what would that be. In this case, LV, the visual range is given 100 miles. This formula is with kilometers, so we're gonna convert it to kilometers, which is 160.9 kilometers. Particle concentration, well, that's down here. So we're gonna have to solve for it in this equation, right? So that becomes 1200 divided by LV. Plug it in, LV 160.9 equals 7.46 micrograms per meter cubed. And as you can see, this is significantly smaller than the NAAQS standard, which was 35. Now for the third question. If the particle concentration in the atmosphere is increased by 1 micrograms per meter cubed, what is the percent decrease in visual range? If the starting visual range was 20 kilometers, and also calculate when it was 200 kilometers. So we're gonna calculate it for two scenarios. Okay, I'm gonna split the paper in two. I'm gonna do the 20 kilometer on this side and the 200 kilometer on this side. Now, what else do they gave us? Be careful, this 1 microgram per meter cubed is not the concentration. This is the change in concentration. Concentration, I'm just gonna call it a C, but this is delta C, okay? Now let's start by finding the current concentration. Let's say this is the current visibility. Then I'm gonna find the current concentration by using the formula, the Koschmeider formula, 1200 divided by 20, this one, and it's gonna give me that we have currently a concentration of 60 micrograms per meter cubed. Now, they're telling me that it'll change by 1. So, I'm gonna take this concentration and change it by 1. Use the formula again, but this time we're gonna solve for the visual range. So with the changed concentration, my visual range is 19.67 kilometers. So as you would have expected, it dropped a little bit, right? Concentration went up, visibility goes down. Now, they want us to find the percent decrease in visual range, so we have to compare these two to each other, and that's what you see here. Percent difference, 1 minus the new divided by the old, both the visual ranges, times 100. Plug it in, there you go. We can find that the visual range decreased by 1.64%. Now, same calculation for the 200 kilometer version. I'm not going to go into as much detail since it's the same logic, but my concentration is only 6. My change, the new, after I increase the concentration, my new visibility is 171, went down from 200, and the percent change is 14.3%. Now, if we want to compare and think about a little bit, what do these two show us? Well, we can see that adding particles to a polluted environment, it will impact visibility less than when we add it to a cleaner environment. All right, remember 60 and the national standard was 35, so this was pretty polluted. This is 6, which is a lot less than the 35, so much cleaner. Adding the same amount of pollutants, the +1, look at the difference. All right, thank you for watching. Please like the video so other people can find it as well, and have a good day.